In this video, let us see how to solve homogeneous differential equation. That is a special form of homogeneous equation where you have dy by dx in the form ax plus by plus c divided by dx plus ey plus f, where c and f, a, b, d, e are constant. So let's look into case 1 where ae is not equal to bd. The coefficient of x and coefficient of y in the denominator when we multiply is not equal to the product of these two variables. So let us consider some example. Dy by dx equals x plus y plus 4 divided by x minus y plus 6. So if you compare this, compare with the given form, that is dy by dx equals ax plus by plus c whole divided by dx plus ey plus of f. So if you compare the coefficients, so here a value is equal to 1, that is a coefficient of x in the numerator is 1. B value is a coefficient of y in the numerator, that is 1. C is equal to 4. D is equal to 1, the coefficient of x in the denominator. E is equal to minus 1, that is y is having minus 1 as its coefficient, and f is equal to minus 6. So as per case 1, we need to check if AE is equal to or not equal to BD. So if we compare the values here, A is 1 multiplied by E, that is minus 1, and then we have BD. B is 1, D is 1. So in this case, we see that minus 1 is not equal to 1. So therefore, we need to apply case 1 to solve this differential equation. So what we do in case 1, when you have the equation where A is not equal to BD, then we put, this is where you're going to check if case 1 is being applied to this differential equation. Now in order to solve this equation, we need to put x is equal to capital X plus of h, where h is a constant, and y, small y, is equal to some capital Y plus of k, where again k is a constant. So after we consider this, let us consider this as equation 1. So we need to differentiate this equation. So on differentiating, x will be dx and capital Dx will be d capital X, where h is a constant, so that becomes 0. Similarly here, y becomes dy, capital Y becomes dy plus of again 0. So if we substitute these two values in equation 1, on substituting, value of x, y, dx, dy in equation 1. What do we obtain? We know that dy is equal to dy whole divided by dx will change to dx, that's equal to x value will be x plus h, y value will be y plus k, and plus of 4 whole divided by, here small x is again capital X plus h minus y plus k minus of 6. Now if you simplify this equation, what you obtain is dy by dx, that is equal to x plus h plus y plus k plus 4 whole divided by x plus h minus y minus k minus of 6. So now what we need to do is, so in order to make this equation homogeneous, we need to uh, take the constants together. So therefore we can rewrite this equation as dy by dx equals x plus y, which are the variables, and then the constants, that is h plus k plus 4 whole divided by x minus y, which is a constant in this case, plus of h minus k minus of 6. So now we can see if this equation has to be homogeneous, then we need to have only x plus y and x minus y, where this constant should tend to 0. So therefore, to make, let us consider as this equation as equation 2. To make the equation homogeneous, to make the equation homogeneous, consider h plus k plus 4 is equal to 0 and h minus k minus 6 is equal to 0. Now we solve these two equations simultaneously. So we can see that k is plus and k is minus here. So these both get cancelled. So what you get is h plus h, that is equal to 2h, and plus 4 minus 6 will give you minus 2 equals 0. And therefore the value of h in this case will be minus 2 on the other side plus 2 divided by 2, and this gives us a value of h equals 1. So once you obtain the value of h, we need to find out the value of y. So consider any one equation from this. So put h is equal to 1 in the equation. So h plus k plus 4 is equal to 0. So putting h is equal to 1, we get 1 plus k plus 4 equals 0. So the value of k will be k plus 5 equal to 0, which gives us the value of k as minus of 5. So considering the constants equal to 0, we have got the values of h and k, that is 1 and 5. So these values we need to keep it as it is, and then since we have considered these values as 0, what does this equation change to? It changes to dy by dx is equal to x plus y by x minus of y. So therefore equation therefore equation 2 changes to, we get it as dy by dx capital dy capital X is equal to x plus y divided by x minus of y. So as I told you, what we are doing here, we are considering this as 0. So this term can be considered as 0, this whole term can be considered as 0, and so we'll be left with x plus y by x minus of y, and that is what we say the equation is homogeneous. So when the equation is homogeneous, we can write, we can solve it further. So we can write here, it is a homogeneous equation. It is a homogeneous equation of order 0, sorry, of degree 0. So you can see the power of x here is 1, here also it's 1, and here also 1 and 1. So 1 minus 1 will give us 0, and therefore we say it is a homogeneous equation of degree 0. So whenever you get a homogeneous equation, then the step is we put let's consider this as equation 3 because we need to make substitution in this. Put uh, capital Y is equal to V capital X. So therefore, if we differentiate this, on differentiating with respect to X, we get Y as dy by dx. Can write with differentiating with respect to capital X, we get dy by dx is equal to v as it is, x with respect to x changes to 1 plus x as it is and v changes to dv by dx. So now we have the value of dy by dx, we have the value of y, we substitute these values in equation 3. Therefore, equation 3 reduces to, so dy we place v plus x dv by dx, that is equal to x, we don't have any substitution, keep x as it is, y changes to vx whole divided by, in the denominator x as it is, again y changes to vx. Now we need to simplify this. V plus x dv by dx, that equals, here we can see x is common, so x can be taken common, so we get 1 plus v divided by x, again common, 1 minus of v, where x and x gets cancelled, so we get here v plus x dv by dx, that equals 1 plus v over 1 minus of v. So now we have in the simplified form, and we know that this is the equation in terms of v and x, we need to try to separate the variables. So how do you separate the variables? We need to take v on one side and the terms on the x with on the other side. Before that, we see that v is in addition with this, we'll take v on the other side, so we get x dv by dx equals 1 plus v over 1 minus v, and here plus v becomes minus v on the other side, so x dv by dx, that equals, if you simplify this further taking the LCM, 1 plus v as it is, this gets multiplied here, so we get minus v, and in the bracket 1 minus of v whole divided by 1 minus v in the denominator. Simplifying, x times dv by dx will be equal to 1 plus v, multiplying v inside, minus of v, minus minus will be plus, v times v is v square whole divided by 1 minus of v. So now just simplify, plus v minus v will be getting cancelled, therefore we get x dv by dx, that is equal to 1 plus of v square divided by 1 minus of v. So now it's time to separate the variables. Take x terms on one side, v on the other side. Remember, dv and dx should be on the numerator. So keeping the dv term as it is, I take the v terms on the other side. This denominator comes to the numerator. So it becomes 1 minus v divided by 1 plus v square. And on the other side, x dx comes to the numerator. And since x in the numerator, it comes to the denominator. Now we can see, therefore, variables are separated. So now, as once the variables are separated, we need to integrate this equation. So let's see what will be the integration for this. So applying integration, so we do on integrating, we had the term as 1 minus v over 1 plus v square dv, that was equal to 1 over x dx. So now, since we have to integrate We'll apply integration on both the sides. Since we can see the numerator is having two terms, we can make it as a single term. So that becomes integration of 1 divided by 1 plus v square dv minus integration of v over 1 plus v square dv, that's equal to integration of 1 over x dx. So now we need to check for the integration here. So integration of 1 divided by 1 plus v square will be tan 1 over a tan inverse of x by a. So it is tan inverse of, so I can just write it as 1 over a. Here a is 1, so 1 over a tan inverse of x by a. So it is v by a minus of, this is, we need to simplify this by considering the denominator as some t. So we get here, so I can show you the integration for this. We need to consider 1 plus v square is equal to some t. So therefore 1 plus v square is equal to t. On differentiating, what do we get here is 0, 1 turns to 0. So v square turns to 2v dv and t will change to dt. So if you see the question, it is having v dv. So what will be integration of v over 1 plus v square dv is, since you know that v dv can be dt by 2. So in place of v dv, I substitute dt over 2 divided by 1 plus v square, we have considered it as t. So considering the constant 1 over 2 outside, it is integration of dt over t. So 1 over 2 as it is, integration of 1 over t will be log of t. So that is nothing but 1 over 2 log of t value, we know it is 1 plus v square. So therefore the integration of this term will be 1 over 2 log of 1 plus of v square. That is equal to, again, integration of 1 over x is log of x. So whenever we have an indefinite integral, it's always required to add the constant of integration, that is c. So now we have done with the integration. Just we'll try to simplify this. That is 1 over 1 will be 1. So we get tan inverse v minus 1 over 2 log of 1 plus v square is equal to log of x plus of c. But if you see the question, we started with x and y, and but we have reached here v. So it's required to go back to the previous, we need to just get it in the form again as y and x. So what we do is we substitute. We had considered y is equal to vx. So therefore v will be equal to, also I can write this as, since we considered y is equal to vx, therefore this will imply that v will be equal to y over x. So put the value of v as y over x. So therefore we get tan inverse, yes it is capital Y over capital X minus of 1 over 2 log of 1 plus v is again y over x whole square, yeah, again put a square bracket here, equal to log of x plus of c. So it's not in the simplified form still, because we had considered that x is equal to capital X plus h. Since we took small x is equal to capital X plus h and small y is equal to y plus k, therefore substituting those values back, and also we know that we have got the value of h and k here. We got the value of h as 1, y value as minus 5. We substitute those values in this. Therefore x can be written as capital X plus 1 and y can be taken as capital Y minus of k, where k was equal to minus 5. So therefore, since you want to substitute here capital X and capital Y, so therefore we can say that capital X is x minus 1 and y is equal to y plus 5. So therefore, so these are all the substitutions we are making in this equation. That is, we get capital X value as x minus 1 and capital Y value as y plus 5. Therefore, the equation reduces to tan inverse of, we had here y by x, so y is y plus 5 by x minus 1 minus 1 over 2, we are looking into this equation, minus 1 over 2 log of, it is 1 plus y square by x square. 1 plus y square, that is y plus 5 whole square by x square, that is x minus 1 whole square, equals log of x plus of c. Log of x, where x is x minus 1 plus of c. Now if you simplify this needs to be simplified. So if you simplify this, we get tan inverse of y plus 5 by x minus 1 minus 1 over 2 as it is log of. So when you simplify this, we get x minus 1 when simplified will be x square plus 1 minus of 2x, and this simplified, it is in the form of a minus b whole square, that is y square plus 25 plus of 5 times 2 10 y whole divided by, we have x minus 1 whole square equal to log of x minus 1 plus of c. So for the simplification, that will imply it is tan inverse of y plus 5 divided by x minus 1 minus 1 over 2 log of x square plus y square minus 2x plus 10y. I'm putting the value, putting it as x square, y square, x, y. Then we have constant plus 1 plus 25, that will be plus of 26 whole divided by x minus 1 whole square, and here we are left with log of x minus of 1 plus of c, which is the required solution. So always remember, when you start with small x, small y, final answer should be again small x and small y, and that will be your solution. So if you like my video, then please like, share and subscribe. And for more videos, please stay connected to my channel.